Hello, welcome to Kaje's Grade A Academy. This is the last tutorial on variation. So the last part is partial variation. So let's recap. We did a direct variation, we did inverse variation, and then we did joint variation. And the last one is partial variation. So they increase gradually in complexity. But as long as you understand the concept, you can always solve any problem. So in partial variation, one quantity varies, is partly constant and partly varies as the other. So as an example, if y is partly constant and partly varies as x, which we can denote by y proportional to x plus c. C is the partial constant, then y is a constant times x plus c, where k and c are the constants of variation. So here we have three pieces of information, and the first two will enable us to solve for the constants k and c simultaneously. So we need to know our simultaneous equations very well. And the third one to solve the problem. So example, the resistance R to the motion of a car is partly constant and partly varies as the square of the speed v. When the car is moving at 30 kilometers per hour, the resistance is 630 Newton, and at 50 kilometers per hour, the resistance is 950 Newton. Find an expression for R in terms of V, and then the second part is the resistance at 80 kilometers per hour. So this is a Pascal. All other things, all things I show here are all Pascals. So let's see. So let's write down our solution. And then we analyze the problem. Say the resistance R, they've given us the symbol. If they don't give you, we'll just say let resistance be this. But here we don't have to let, we just use it. The resistance R to the motion of a car is partly constant. So the resistance R is partly constant and partly varies as the square of the speed. So varies as the square of the speed v squared and partly constant. This is your statement. So this is our statement, a statement of variation. And I say when the car is moved, so let's just make it the equation. So it means that what? R is equal to K times V squared and then plus C. So this is the equation. This is equation. Now, the question says that find an expression for R in terms of V. So the expression is the equation. So we need to find the values of K and then C and rewrite the equation. So it says when the car is moving at 30 kilometers per hour, the resistance is 630. So let's say first information, first info. The resistance is 630 Newton. So 630 is equal to K times V. And they say when the car is moving at 30 kilometers per hour. So that is times 30 squared plus C. So this will give us 630. Oh, let me erase it. This is not clear. So this will give us 630 is equal to 30 squared is 900 K and plus C. This is equation 1. Let's go to the next one. It says that when it is moving at 50 kilometers per hour, the resistance is 950. So second information, we have second info. Oh, not info, info. Second info. Second info, we are told the resistance is 950. So 950 is equal to K, and it is moving at 50. So times 50 squared and then plus C, which will give us 950 is equal to 50 squared. That is going to give us 2,500 K plus C, and that is our equation 2. So we have to solve equation 1 and 2 simultaneously, and this is simultaneous equation, so you need to know how to solve simultaneous equations. So let's see what we want to. We can eliminate by we eliminate C because the C's are equal. So we eliminate C and then we can find. So let's say equation 2 minus equation 1, that's 950 minus 630. We're going to have 320 is equal to 2500 minus 900 is going to give us 1600K. And then we'll divide by 1600. So if I divide here by 1600, here to by 1600, this will cancel that. Use your calculator, please. And then we're going to have 0.2 is equal to K. So if I know the value of K, I substitute it equation 1 to get. So put K is equal to 0.2 in 1. And therefore, we're going to get what? 630 is equal to 900 times 0.2, and then plus C. So plus C, and then we get what? 630 is going to give us 180 plus C. So that will give us, you solve this, you have 450 is equal to C. So we get our values of C and K, and then we can write our equation as what? R is equal to K. Our K, we've gotten our K to be 0.2, so 0.2 V squared, and then plus C, and C is 450. That is our expression. So the other thing to do is you plug in the information. The second part, the resistance at 80 kilometers per hour. So you just plug in 80 in this formula and you are there. Okay, thanks for watching, and this is the final part of variation. I hope it has helped, and please, if you want more, you can look into my book, and there are several questions from all the years that have been solved, and you get to practice more. Okay, thanks for watching, and look out for the next video.